Okay, welcome everyone. Today I'm going to give you an introduction to end-to-end monitoring of container infrastructure with Prometheus and the Prometheus Operator. So really quickly, I'm Max. Hi, I'm a test engineer at CoreOS. I'm mostly working with the Prometheus team, helping them spinning up big Kubernetes clusters, testing their stuff inside, doing that all automated and taking everything back down. You can find me pretty much anywhere at Inden. And if you don't want to ask questions during the talk, but rather do that digitally, feel free to ping me via email. Okay, what does CoreOS do? We secure, simplify, and automate container infrastructure. Those are a bunch of buzzwords right here. So let's see how we actually do this. We got a bunch of projects. One of them, for example, is Tectonic and Quay. Tectonic would be our upstream vanilla Kubernetes, which we enrich by all kinds of stuff, so you're production ready right away, for example, monitoring. And Quay would be our container registry, like Docker Hub, with very nice Kubernetes integrations. Now, what we're probably most well known for is our open source projects. So, for example, Container Linux, back in the time that was CoreOS, where the name actually came from. It's a very basic Linux distribution for running your container infrastructure. The most asked question here, it's not the system that runs inside of your container, but it's your host system underneath. Then we have Rocket as a container engine. We heard earlier by the BlaBlaCast how to use that. We have Flannel as an overlay network, or etcd as a database, distributed database, where actually Kubernetes is highly invested into and based on. And next to these projects that we created our own, we have Kubernetes and Prometheus and many more projects that we contribute to, so very present in the open source community. Yeah, very invested into this. Okay, let's jump into monitoring today. We want to talk about monitoring, right? So why monitoring? Well, when I'm a startup, I probably don't care about monitoring at the very beginning. But you care about monitoring until somebody tells you on Twitter that your service is down. You don't want that to happen. You want to see before your service goes down that your service is going to be down. So that's why you probably want to implement monitoring. And that can be quite difficult in container infrastructure where everything is moving all the time. So the first thing about monitoring, we want monitoring to alert, right? We want something to wake us up in the middle of the night telling us our disks are running full or we can't handle the load anymore. And the second thing to monitoring is long-term trend analysis. So we got our short-term stuff like alerting and our long-term stuff like, for example, am I going to survive Black Friday next year? Or am I only serving 500s on my endpoints? And so on. So all kinds of different questions. How much load does my API take right now? And which API endpoints are most used? So all kinds of different questions that we want to answer today via monitoring. Okay, now monitoring, we're looking at a specific tool here that would be Prometheus. Prometheus is an open source monitoring tool. Pretty much anything I'm talking about today is open source. You can look at it on GitHub. Anything that I'm going to show today is definitely going to be open source. So Prometheus, open source, GitHub/Prometheus/Prometheus. Check that out. It's built by SoundCloud. Most of the main core maintainers are from SoundCloud. And the story behind this is highly inspired by Borgmon. So when there's this, it happens very often that when people leave Google, they miss the infrastructure software they have there. And they're looking in the open source world and can't find it, and they create their own stuff. And same thing with Prometheus. So a lot of people from Google went to SoundCloud, missing a good monitoring tool. They remembered how Borgmon, the monitoring tool of Borg, the container orchestrator at Google, worked and developed that in the open as an open source project. So that's how Prometheus came along. So a little bit more technical, what is Prometheus? What is it all about? It's a pull-based monitoring system. It follows the church of pull. There are huge discussions whether your monitoring system should do pull or push. Pull just means your monitoring system looks after your apps. It goes to your apps and scrapes the metrics off and checks if everything is working right. Whereas push, your application pushes the metrics to your monitoring system. Now, Prometheus is in the end just a time series database. It goes along to your apps, scrapes the data from there, and saves it into its database. And what is really nice about Prometheus here is that it has a multi-dimensional data structure underneath, where you can do great queries and handle this data in an awesome way. Then next up, Prometheus is about metrics. It's not about logging, and it's definitely not about tracing. I'll jump a little bit into why it's not about logging at a later time. And well, it's not about tracing because it simply doesn't have that functionality. So it does one thing, and it does that one thing really good. And last, when it comes to your monitoring system, this is like the last thing that's going to wake you up in the middle of the night. You want no magic here. And I'm not talking about artificial intelligence today, sorry. I'm not talking about blockchains either. I'm just talking about how to configure your monitoring system. So here's no magic involved today. Okay, so we want to monitor something. Let's look at what we can monitor. We got 3 targets. That can be anything, your Linux kernel, that can be your load balancer, that can just be your application. And what we do with those targets, each of them exposes a /metrics endpoint. That's just an HTTP endpoint where the monitoring system can go to and look if the application is working right and how the application is currently doing. Now you're probably saying, the Linux kernel, how am I going to expose an HTTP endpoint out there? Good luck getting that upstream. So what we do here is we offer exporters. So these are just little sidecars that you run next to your Linux kernel, and those exporters look how the kernel is doing right now and exposing that as an HTTP endpoint. Next up, we got our targets. We got them nicely instrumented by a /metrics endpoint. We deploy Prometheus, and now we tell Prometheus where those targets are, and Prometheus comes along as a pull-based monitoring system every 15 seconds and scrapes our targets and checks if they are all doing well. Now, this is nice. We got all the data. We probably want to do something with that data. Oh, hang on. I'm missing something. I'm sorry. Let's look at the /metrics endpoint here. Little jump here. So if you have the target on the /metrics endpoint, as I said, it's just an HTTP endpoint. This is one example of a metric that would be exposed here. Just a comment above, and then you got the metric name. You got labels that actually do make the multidimensional data model in the end. And then we have the value at the very end. And how you have to think about this is, for example, if you have your application and you have your API on that application, a user comes and does a request against your API, and then the application is going to increment this HTTP request total counter. And every 15 seconds, Prometheus comes by, scrapes that number, and checks what happened here. So now here you see Prometheus doesn't know about every single request, but only knows about the requests in those 15 seconds time range. And that's why Prometheus is not good for logging, where you probably want to be very specific and want to know exactly when which HTTP request happened. Okay, so this is how we scrape this data. And as I jumped forward earlier, we want to do something with that data. So Prometheus exposes an endpoint to query that data. And that's just the PromQL, the Prometheus query language. Now, how would that look like? Why are we writing a new query language? Why are we not just using SQL? Well, this is specifically targeted at time series data and at answering monitoring questions. It's about answering monitoring questions here. So let's look at a little example. Let's look how our service is doing by seeing how many HTTP errors as a percentage it's serving right now. And let's write a query for that. So what we do is we sum ordered by path. That's the endpoint path of our API. And we do a rate over HTTP requests, filter it by status 500, so the ones that didn't succeed, and do that by the last 5 minutes. And we divide that by the same thing, but just not filtered by the 500 errors. And what Prometheus returns us here is just a simple result. This is nice, you got data out of this, but you probably don't want to show this anybody. Everybody wants fancy dashboards or something. So we need a little bit more than this. And what Prometheus adds on to this, as it's an open source project and it's this huge ecosystem, it has a lot of bunch of components on top of this. For example, the web UI that talks to this PromQL endpoint, or the different dashboarding tools, like, for example, Grafana. There's a huge amount of integrations. Now, we can display that data over dashboards. We can hang fancy screens into our offices and look at our dashboards and look how great we're doing and how many requests we get per second. This is wonderful, but this still doesn't wake you up in the middle of the night. You don't want to set an alarm every hour, waking you up and looking at your dashboards if your services are doing well. So what you probably want is your monitoring system to tell you when something is going wrong. And in order for the monitoring system to be able to tell you something is going wrong, it needs to know what is this state called wrong. So you do that by alert definitions. So you give Prometheus definitions what a bad state would be. And this looks like this. Again, we just give it an alert name, in this case, disk running full. And here you see the power of PromQL. Blew my mind a little bit. We just do a simple linear prediction based on the data of the current hour for the next 4 hours, whether my disks are running full or not. And here you see equation, and it evaluates and compares it to 0. If that equation returns true, Prometheus knows something is going wrong and needs to alert you. Now, you give Prometheus those alert definitions, you tell Prometheus what is a wrong state or a bad state, and then Prometheus goes over its data that it scraped from all your targets every 1 minute, or whatever you configure it, and looks if anything is going wrong. And if so, it can alert you. But it doesn't do that right away, but it sends alerts on to Alert Manager. Now, you might be asking, why another component in this? That might fail, something can get interrupted in between. But we're separating concerns here. So let's look into what Alert Manager does. Real quick, like, scrape your targets, Prometheus scrapes those targets, evaluates the alerts, and sends it on to Alert Manager. Let's jump into Alert Manager here. So you probably want, for high availability, not to run one Prometheus, but probably multiple Prometheuses. And you give each Prometheus the same configuration, so each Prometheus is going to alert at the same time, hey, your disks are running full. And when an engineer is paged, he doesn't want alerts to be sent multiple times. He is in a rush, he is very nervous, he wants to fix the problem and not wants to be bugged by all the noise. So what we do here with Alert Manager, we deduplicate alerts. So when 2 duplicate alerts come in, we deduplicate and only send 1 on. Then in addition, we group alerts. For example, if your storage cluster is going down, there are probably, I don't know, 1,000 disks in there. If you have an alert for each disk, you get 1,000 alerts. That's not what you want. So you probably want to group by cluster or by alert name, and thereby your engineers only get 1 alert again. And then, from there on, when your storage cluster dies, you don't want to wake up your front-end engineers. They can stay asleep, but instead you want to wake up your storage guys. So here, what you do is you define your organizational structure, and then Alert Manager knows where to route which alert to. OK, so deduplicating, grouping, and routing from here. Let's move on. So Alert Manager has all of this done with your alerts, and then it sends it on to either PagerDuty or email or Slack or whatever you want here. There's a huge amount of integrations again. OK, now we got our monitoring pretty much set up. We got our targets, we got our Prometheus, we got our Alert Manager. This is nice, this is great. Let's look a little bit more into detail. And what I want to separate here is the space of monitoring into 2 things, into application monitoring and into cluster monitoring. And let's first jump into cluster monitoring. So cluster monitoring I'll do from the example of Kubernetes. Who here is familiar with Kubernetes? A little bit? Yes, quite some people. I'll still introduce it really quickly. I can't explain it. That's more than one talk. So Kubernetes is a platform for running your containerized applications. And it was announced by 2014 by Google. It's heavily influenced by Borg and Omega, two internal container orchestrators. And what Google did, it take those ideas and learnings and moved that on to the public. But it didn't do that by moving code to the public, but instead developing those ideas as a rewrite new in the public with the community. So in 2015, they released version 1, and right now and gave it to the CNCF, the Cloud Native Computing Foundation, with that new release. So now it's not owned by Google anymore. They still have around 45% of contributions are still from Google, but all other contributions by thousands of other developers from all over the world, from all kinds of different companies. So it's a very, very healthy open source project here. So how does Kubernetes look like? If we want to monitor, it, we need to know how it looks like. So it has a bunch of components, for example, on the master node. And that's the API server, the thing you talk to, the etcd, the database, the controller manager, the scheduler who decides which lands, the kubedns, and all of this stuff. And they all expose Prometheus metrics by default. This is amazing for anybody administrating Kubernetes. You can just set up Prometheus, and it all works by default really easily without a lot of setup. And next to that master, you got a bunch of workers where you actually run your workload. Again, there are a bunch of components on there, and they all expose Prometheus metrics again. This is, really easy for anybody administrating this. So we got our cluster monitoring done. Let's look into application monitoring a little bit. You got your application. You instrument it by some of our client libraries. There's pretty much for any language, there are libraries and tutorials how you can instrument your app. You run not one version of that app, but probably multiple ones, and you put services in front of them to group them, and now you deploy your Prometheus. And now, how does Prometheus find out about your apps? Well, Prometheus has nice integrations with all kinds of different cluster management tools. And one of them is, for example, Kubernetes. So Prometheus talks to Kubernetes, and then it knows where to find your pods and can scrape those pods. Cool. That's just one service discovery integration. Prometheus has a bunch of them. You can define targets statically. You can do DNS discovery. You can do Kubernetes discovery. I think for AWS there's something as well. So huge ecosystem here. Now we got everything done. We went through everything in the theory. This is nice, this is easy, that's no problem. You can probably go home now and set this all up. No problem, just spin up a Kubernetes cluster. But it's actually not. Monitoring is a lot of hard work, and monitoring is a lot of configuration. So it's not that easy. I made it seem easy, but for example, for cluster monitoring, it's easy with Prometheus for sure, but for cluster monitoring, you have to spin up a Prometheus. How does that look like? You have to create a stateful set, you have to mount the configuration file in there. Now you have to tell Prometheus where to find all these components. In terms of application monitoring, you have to tell it where all your applications are. Whenever an application changes, you have to configure Prometheus again. You have to set up Alert Manager. You probably want to run Alert Manager multiple times, so an entire cluster. You have to tell each Alert Manager where the other one is, and so on, and so on, and so on. So a lot of configuration here. And why do we do this? So Prometheus is a stateful app, and operating stateful applications is always difficult. Databases are really difficult, and in the end, Prometheus is just a database underneath. And Prometheus is really difficult to configure. It's not just made for Kubernetes, but it's pretty much made for any container orchestration tool. So what I suggest here, by introducing the Prometheus operator, is that we write an abstraction on top of this. So we write an abstraction how to use Prometheus inside of your Kubernetes cluster. And that's done by Prometheus operators. And you might be asking what are operators. I'll jump into that really quickly. What is a Kubernetes operator? The idea is that we got a lot of skills, we got a lot of learnings. For example, if you guys operate a MySQL database for 5 years already, you know exactly how to operate that thing. And some processes might be repeating, and you might be able to put that into software and just automate it. So the idea of operators is put your knowledge into software, and you get an operator out of it. And that operator you deploy in your Kubernetes cluster, and it takes care of your application, knowing that domain-specific knowledge. Now, the Prometheus operator makes Prometheus itself as an abstraction on top of Kubernetes, Kubernetes native. So you just talk to Kubernetes, please spin up a Prometheus. I'll look into details a little bit after this. And in addition, it automates the management and the upgrades of Prometheus and Alert Manager. So it's really easy to use. And then on top of that abstraction, what there is also is kubeprometheus. kubeprometheus gives you an opinionated way how to monitor your Kubernetes clusters. We, as Prometheus maintainers and Kubernetes users, we know exactly how to monitor your Kubernetes cluster. So why don't we give that knowledge on to you, and you can just use it in terms of software. So what kubeprometheus gives you is it's a single command. We'll look into it. It spins up Prometheus cluster, an Alert Manager cluster. It sets up alerting rules because it turns out when your master goes down or your API server is down, it doesn't matter if you're Google or a little startup, you always want to be alerted. So we can streamline this and all use the same rules here. And in addition, what kubeprometheus does as well is it sets up dashboarding and so on. Okay, I'll demo this really quickly, so I'm not just saying anything here. Hope this works. Down here, you see kubectl-n monitoring get pods. This is just showing you the current state of my cluster. I spin up a Kubernetes cluster before this. So right now, you see we have no resources. And what I can do now here is deploy, just execute my deploy script. That's just a kubeprometheus deploy script. It will set up everything. And run this. And now it's going to create the Prometheus operator. There you go. It's coming up. Now Prometheus operator registers third-party resources on Kubernetes. Hope this moves on and the internet connection is working well. Now you see kube state metrics starting up, so a little exporter that tells us about the current state of Kubernetes. You got Grafana starting up as a dashboarding tool, and so on. Prometheus in a cluster, for now it's only one. Yeah, and the script is done, and this is slowly going on here. You see Alert Manager starting up here. So everything ready to go for you. And what I'm going to do here is just expose this really quickly so we can access it from outside. Here. Expose it here. Expose it that here as well. Expose that. And what I hope to happen, yes, perfect. And now we have our Prometheus up and running here. You see here all the targets that it already scrapes. So you have, for example, your Alert Manager cluster that it monitors, your API server, your kube state metrics, so you know everything about Kubernetes itself, your kubelet, so where actually who actually runs your containers, Prometheus itself, and the Prometheus operator. And then you can, for example, go into configuration. Here you see it already discovered the other alert managers. You can look into rules. These are all the alerting rules that we wrote for you. So whenever something happens, it's going to wake you up. And from there on, Prometheus sends those alerts on to the alert manager. You only have one alert right now, the deadman switch for now. I can go into greater detail after that. And then from there on, we also have fancy dashboards. They should not look like this for now. No data endpoints for now. This always takes a little while. But what we offer here is Grafana with all kinds of different configured dashboards, so you're up and running and put those up on your nice screens in the office. OK, single command to install. Let me go back into presentation here. So we got Prometheus, we got our demo. Let's do a really quick recap. What is Prometheus? Prometheus is a pull-based monitoring system. It follows the Church of Pull. Multi-dimensional data model underneath. It's structured. It is used to collect metrics. It's not about logging. It's not about tracing. And it's definitely no magic here. Prometheus scrapes your targets. Then every 15 seconds, you give it the alert definitions. Prometheus sends alerts to Alert Manager on, and then Alert Manager sends that on to PagerDuty or whatever you want to integrate here. And then last, Prometheus is very general tool, so what we give you from CoreOS is here Prometheus Operator in the Prometheus project, which gives you an opinionated way how to monitor your Kubernetes clusters, all entirely automated here. Okay, where can you go from here? If you really like this, there's Prometheus.io. You find great getting started guides here. And there's github.com/CoreOS/Prometheus Operator, and you can find the Prometheus project here as well. Okay, if you really want to get involved into this, we are also hiring. We are hiring in San Francisco, New York, and Berlin. Make sure to find me after the conference or shoot us an email if you want to join. And yeah, that's it. I'm Max. Shoot out questions if you have.